Good evening, everybody, and welcome to this webinar on the use of ultraviolet radiation for surface and air disinfection, hosted by the ISLE Indian Society of Lighting Engineers, Mumbai State Center. Presented by Vijay Shigli. I would like to thank Dr. Barjatia for promoting this event. I would like to specially thank Mr. Rashmir Bhuta for his motivation to start this series of webinars. I would like to thank Mr. Anil Walia for his inputs in preparation this presentation. I would like to acknowledge and thank the many researchers whose papers I have referred and whose materials may be slightly used in this presentation for educational purposes, without which it would not have been possible to make this presentation. Now, coming to light, it is a well-known fact that the electromagnetic spectrum is having effect on microorganisms. Various wavelengths of the electromagnetic spectrum have effect on different types of microorganisms. The UVC wavelength or the UVC wavelength from 200 to 280 nanometers will be discussed in detail. The other wavelengths like the UVA, which is between 320 to 400 nanometers, is used for photocatalysis. The visible light from 400 to 700 nanometers is used for PDI or photodynamic inactivation, and the near and far infrared lasers are used for femtosecond. All of the techniques that are listed that I said just now are having disinfection on microorganisms to some degree and can kill or inactivate bacteria, fungi, viruses, and toxins in more or less challenging environments. These are a few examples of how the germicidal properties of sunlight is being used, or the UV radiations from the sunlight are being used. Way back in 1917, during the influenza pandemic, patients were exposed to sunlight for a few hours so that they could get disinfected from the sun's rays. The process of disinfecting water by keeping it in the sunlight has been quite old. For example, bottles are kept outside in the exposed to the sunlight to have them disinfected. The natural lakes and ponds do get disinfected from the rays of the sunlight. It is a well-known fact that babies are exposed for some period of time during a day to have that disinfection of their bodies using sunlight. The other reason is also for using for absorption of the vitamin D. Now coming to what is ultraviolet radiation, it is the wavelength, it is the electromagnetic wavelength between the X-rays and the visible light. The biggest source of ultraviolet radiation is the sun. Approximately 10% of the sun's electromagnetic radiation is ultraviolet. Ultraviolet radiations can also be produced artificially by electric arcs or some specialized lamps such as the mercury vapor lamp, tanning lamps, or black lights. Now even UV LEDs are available. The electromagnetic radiation of the ultraviolet spectrum is further divided into three major parts: the short wave, middle wave, and long wave, which we will be discussing in detail a bit shortly. Now, of the three wavelengths, UVA and UVB do reach the Earth's atmosphere, whereas UVC is completely eliminated as it does not penetrate the Earth's atmosphere and reach the Earth's surface. Coming to the three types of ultraviolet radiations, UVA, it ranges between 315 and 400 nanometer. It is also called as the long wavelength or the long wave. It accounts for approximately 95% of the UV radiation reaching the Earth's surface. It can penetrate into the deeper layers of the skin and is responsible for the immediate tanning effect. It also contributes to skin aging and wrinkling. For a long time, it was thought that UVA could not cause any lasting damage, but in recent studies, it has been found that it is photocarcinogenic and enhances the development of skin cancers. Coming to UVB or the middle wavelength, the middle wave as it is referred to as, it is a very biologically active but cannot penetrate beyond the superficial skin layers. It is responsible for delayed tanning and causing skin burns. In addition to these short-term effects, it enhances skin aging and significantly promotes the development of skin cancer. Most of the solar UVB is filtered by the atmosphere, but there is a great amount that reaches the surface also. UVC is the short wavelength. It has the highest damaging effect. However, it is completely filtered by the atmosphere and does not reach the Earth's surface. This wavelength, uh, for its germicidal properties, is used for virus and bacteria disinfection, deactivation. The wavelength between 200 to 280 nanometers is of special photobiological importance because of its effect for disinfection, the highest effect for disinfection. Now going back into the history a bit, the first patents for low pressure mercury vapor lamps were issued way back in 1886. Some work by Wheatstone in this field in the early 80s. The first mercury vapor UV lamps, which had wide acceptance in the market, were developed by Mr. Peter Hewitt and he got the patent for that. There are books and papers from the early to mid written in the early and mid 80s showing great amount of research done on ultraviolet radiation and its germicidal properties. For example, it's Mr. Matthew Lucage's books on ultraviolet radiation, its properties, production, and measurement way back in 1922. Again in 1946, from the same author on applications of germicidal, erythritol, and infrared energy. UV was very widely used in the 1930s for air disinfection to control the measles pandemic then. It was also widely used in controlling TB and influenza pandemics. In fact, it has been found that use of UV in air disinfection methods has reduced has shown results reducing TB by 80%, the transmission of the disease by 80%. It is widely used in the treatment of water, especially to control the E. coli bacteria. The effect of UV light breaking the DNA and attacking its nucleic acids was first established in the early 1960s. Now, I'm bringing you to some of the few of the chronological events with respect to UV that have happened. Way back in 1877, Downs and Blunt discovered the ability of sunlight to prevent microbial growth. If you refer to these specific two events, that is in 1935, Wells and Fay demonstrated the ability of UVGI to effectively inactivate airborne microorganisms and prove the concept of infection via the airborne route. After again a gap in the mid 80s and the early 90s, in the United States there was a resurgence of tuberculosis, and during this time the effect of UV had found uh, renewed interest again in the year 2020 because of the COVID-19 and novel coronavirus. The germicidal properties of UV have found renewed interest again. These are some of the most commonly transmitted airborne microorganisms, especially if you consider tuberculosis, which affected nearly 27 lakh people in 2018 and killed nearly 4.5 lakh people in India. Then you have the SARS virus, which is from the coronavirus family. You have the anthrax, which is a biowarfare agent, and it has been found that UVC has been very effective in deactivation of these viruses. UVC is also a very good agent for some of the defense in biowarfare. In fact, there are many studies suggesting how to use ultraviolet and electromagnetic spectrums in biowarfares. Uh, what is germicidal UV and why it is referred as such? The ultraviolet radiation, people are the word radiation or its ionizing radiation with respect to X-rays and gamma rays, people get confused with it, and just to avoid that confusion, the word germicidal UV is used. Now, ultraviolet germicidal irradiation, it is the process by which an object is exposed to UV radiation. The process of exposing an object to UV radiation is called as ultraviolet germicidal irradiation. Ultraviolet light is another non-technical term, but light as such is actually for the visible spectrum. Uh, how does UVC work for killing the bacteria or viruses? The UV rays directly affect the nucleic acid of a microorganism which is present in the DNA or the RNA of the bacteria or virus, and thus making them inactive. This damage to the nucleic acid will make their ability to multiply. It destroys the ability to multiply and cause diseases further. Here is the graph showing the relative germicidal efficacy against the wavelength. If you see this, uh, it has been found most effective in the 265 to 270 nanometer range. Now the nearest lamp that is available to us, which is the mercury vapor lamp, emitting 254 nanometers, is widely used. On the right side, you can see the susceptibility of microorganism groups from highest to lowest. Susceptibility against UVC inactivation. How do viruses transmit? The most common are airborne transmission, droplet transmission, and contact transmission. In case of airborne transmission, the droplet sizes are less than 10 micrometers. In case of droplet transmission, less than it is between 10 and 100 micrometers. And in case of settled droplets, it is greater than 100 micrometers. Now the airborne transmission and droplet transmission directly affect the lungs because the person inhaling them will take the viruses directly to their lungs or the respiratory tracts. Normally, the airborne reaches your lower respiratory tract directly, and the droplet transmission reaches your upper respiratory tract. Now, contact in case of contact transmission, it is passed on from your touch of your body to affected surfaces, and from there it is picked up, and then by various means it may reach your lungs. For example, it may be your mouth or your eyes or your nose. Uh, Here is a graph of an experiment that was done to check the effectiveness of ultraviolet C and ultraviolet A on SARS coronavirus. If you see the graph clearly shows that UVC or the germicidal UV is highly effective as compared to UVA on deactivating microorganisms. What are the methods of disinfection used in UVGI or GUV? One is the induct GUV air disinfection, in-room air handlers, upper room GUV air disinfection, whole room GUV air and surface disinfection, mobile or robotic GUV for high-touch area surfaces, targeted GUV for shadowed areas. We shall discuss each of these methods in brief. In the induct air disinfection method, UV lamps, the germicidal UV lamps are placed in ducts or AC ducts or the ventilation ducts, and the air passing over this gets disinfected. So this disinfected clean air is then passed to the room or occupied area. There are a lot of parameters that go into designing this system. There is the amount of lamps required for a particular volume and flow rate of air. It has been found that with this method, you normally get around 2 to 3 ACH or air changes per hour. But it is generally recommended to have a minimum of 8 to 12 ACH to have proper disinfection in an occupied room. In this method, there have been found to have a lot of accidental hazards because of maintenance staff or untrained maintenance staff trying to repair the systems. The second negative point here is there is no identification of failure of these lamps. But with current electronics, it will be possible if properly used and proper control methods are used to identify and indicate lamp failures. This type of method of air disinfection can be used in occupied rooms with proper precautions, avoiding UV leakage. Next is the in-room GUV air recirculators. In this case, you have a recirculating unit, and within this unit, you have the UV lamps placed. Air is sucked in from one end and passed over UV radiation, and the disinfected air comes out from the other end of the unit. It has been found to give only 1 to 2 ACH at the max. So this is effective if a very large unit is used in a very small room. This can be used in conjunction with other methods of disinfection. This is having one specific use when it can be placed near patients so that the air surrounding them is continuously disinfected. This type of air handlers can be used in occupied rooms. Next, coming to upper room GUV or UVGI. In this case, the volume of air above 7 feet of height is disinfected using UV luminers. In one of the methods, the luminers can be placed on the sides and directed slightly upwards so that the air above gets disinfected. Now, this disinfected air is continuously recirculated into the from upper part to the lower part of the room by mechanical or natural ventilation. Even simple fans will do this job. Here, normally two types of luminers are used. One is the open luminers, and one is the luminers with lowers. The luminers with lowers give a narrow band, a very narrow band of radiation. So it is very useful in controlling the beam of the luminaire. But the efficiency of this lowered luminaires is very less, around 30% of the open luminaires. Here, care should be taken that when you design and install these products, they are done properly and they do not directly or indirectly send the rays downwards where below the 7 feet height where people are working or occupied. One of the major things that happens in such upper room GUVs is the reflected radiation coming down and hitting people, causing discomfort to the people working in the area and affecting them. So care should be taken when you design and install these products. The consideration of reflective material of the ceilings and walls. There have been incidents where people install this, and after finding that there is a lot of reflected UV affecting the people, after people started complaining of eye burns and skin burns, they had to completely redo their ceilings with new non-reflective or minimal reflective paints or treatments. Here is an indicative image showing natural airflow over a band of UV radiation. Now, this air is recirculated over the UV beam, which gets disinfected and continuously recirculated by natural convection from top to bottom. So, there is a continuous process of air disinfection here. It has been found to be very, very effective, especially in the treatment of or the transmittance of controlling the transmittance of tuberculosis. Results have shown to be that the effect has been up to 80%. This can be used in occupied rooms, but with great precautions. Here are a few installation images of upper room GUVs. This is the Butaro Hospital from Rwanda. Here you can see the luminaires that are mounted on the wall, the upper room GUV luminaires, and in the first image you can see a large industrial fan which is recirculating the air from top to bottom, or the disinfect air after disinfecting moving down. There is continuous recirculation of the air. In the second image you can see there is no fan, but natural air ventilation is used for this. Now this type of process is found to be equivalent to nearly 20 or reach up to 20 ACHs, equivalent ACHs. Here we have a small study that was done with UV on and UV off to check the BCG bacteria growth colonies. When the UV was off, the air there had nearly 2 ACHs, whereas after switching on the UV, the same air was equivalent to nearly 17. It was equivalent to nearly 12 ACH. Next comes the whole room GUV. In this process, normally lamps are installed on top, or we use floor standing systems to disinfect complete rooms. The limitation here is the shadowed areas are not disinfected because the UV rays cannot penetrate to through many a material, so it doesn't reach those surfaces to disinfect them. Here care should be taken that most of the surfaces that you are going to disinfect should be clean enough, because if you have any layer of material on those surfaces, the material below or the surface below that layer may not get properly disinfected because of the short wavelength. The penetration level is very less. This cannot be operated in occupied rooms. and this unit should be handled by qualified and trained staff. And secondly, in these cases, you should provide safety mechanisms such as sensors which can detect human presence and immediately turn off the system. Uh, we can also go in for mobile or robotic GUV. These are normally trolleys mounted with GUV lamps and normally used for disinfection of various types of rooms, especially the operation theaters and hotel rooms. This is even used to this methodology is even used to disinfect aircraft. And below is the photograph of unit that is showing you the disinfection being done using this type of methodology in aircraft. This methodology cannot be used in occupied rooms, and you need trained personnel to operate this equipment. Targeted GUE for shadowed areas. Now, in many cases, what is happening is that since the luminaire for whole room GUE or top lighting, or when you are using the trolleys, there are many surfaces that do not get exposed to the UV radiation because of shadow effect. Now, and there are many such areas which are not reachable easily. In this case, we can use handheld devices, but you have to be very careful when using this because the person using this has to be properly trained and use proper PPE. Also, nowadays there are a lot of products that are coming into the market which have a questionable effectiveness. Here is an example of a combination of upper room GUV and induct system. The image clearly shows use of UV lights before and after the coils, the cooling coils. Care should be taken that the material selected in the filter should be resistant to UV radiation or it can destroy the filter. In this kind of systems, it has been found to be effective, very effective. And this type of systems can provide more than 20 ACHs or equivalent ACHs. Now, coming to dosage of UVC. Now, dosage is a function of the intensity of the UV radiation and time. The calculations is a very complex process with where you have to consider a lot of parameters and environmental conditions to calculate them. It is expressed in joules per meter square or millijoules per centimeter square. It is also known as fluence. Now, there are various mathematical models available to calculate the dosage required for deactivation of microorganisms for surface and air disinfection. There are also many evidence-based models. For example, for disinfection of tuberculosis in a GUV system, the requirement is of 17 milliwatt radiometric output of 254 nanometer wavelength UV radiation for a meter cube of volume of air. You can see here the UV dosage fluence is a function of intensity and time. This is expressed in various methods where you can define it, the dosage defined for a particular amount of deactivation, that is 90%, 99%, which is also called as a log kill. For example, a 1 log kill is 90%, 2 log kill is 99%, and such, where 4 log kill is 99.99% disinfection or deactivation of viruses. Here is a summary of effect of UV on various types of coronaviruses. Of course, this is not including the current novel coronavirus or the COVID-19. But depending on this available data and doing some averaging, so an effective dose of 67 nanometers for a D90 or a one log kill should be sufficient. K is actually a constant for a particular type of organism for UV disinfection, and this factor is multiplying factor that is used in calculations of UV disinfection. Here is some data for the type of or wattage of lamp or the dosage that is required to disinfect or deactivate these bacteria or viruses. Now, when we just plot them on a graph, the inactivation required for a 4 log kill, it has been found that typically 40 millijoules per centimeter square is effective enough for most of the virus deactivations. Of course, we still do not have the actual data for the coronavirus or COVID-19 yet. But looking on to the average system, I think so, as I said in the earlier slide, where it showed on if you take an average 67 millijoules per centimeter square should be sufficient enough to kill such a type of virus. But this is only by the average method that we are coming down to, and not tried and tested method. So we cannot claim directly that this is the dosage required for the COVID-19. The data is not yet available. Now coming to various types of ultraviolet lamps. You have the most common low pressure mercury vapor lamps and the medium pressure mercury vapor lamps. Then you have the xenon arc lamps, the examer or rear gas lamps, and you have the UV LEDs. In case of low pressure mercury vapor lamps, the patent for which was issued way back in 1886, these lamps typically give a 254 nanometer wavelength for approximately above 90% of their output. So one of the major lamps that is used for virus deactivation or disinfection. There are small traces of other wavelengths like something in the 300 range, the 360, 365 range, and something in the 415 range. But the intensities of these are very less as compared to the total output, and quite safe enough for use in systems. These are very similar to the fluorescent lamps. Basically, it is fluorescent lamps without the inner phosphor coating. Now, when you come to medium pressure vapor, mercury vapor lamps, if you see the graph here and the comparison of the low pressure and the medium pressure lamps, it gives out a very wide range of wavelengths from the lamp. Therefore, this is normally not used for GUV applications except for the air handling systems or very large water tanks where water disinfection is done. Then we come to excimer lamps or excited molecule lamps. Now, in these lamps, what happens is you have a glass tube in which a particular type of noble gas is filled in, and the molecules inside are excited by high energy electrons. Now this produces plasma in the gas chamber, and this can be easily immediately extinguished. And when it is extinguished, when it starts coming, when these excited molecules start coming back to their original position, they emit various types of electromagnetic radiation. With by using different types of gas materials or the noble gases, uh, you can get very accurate or small wavelengths anywhere between 172 to 310 nanometers. For example, the krypton chloride gas is found to give UV in the range of 222 nanometer band. Now, specifically, this narrow band for shortwave UV and to the very lower side is under a great amount of research for its effectiveness in disinfection, as this is found to be not very affecting human body or animals. There is a lot of research going on to see that whether we can use the 220 or 222 nanometer wavelength band for disinfection where in human occupation areas. Now coming to UV LEDs. LEDs are very small units. They can be placed anywhere. You can design luminous in such a way and that you can design a space first and then put in these lamps. The beams can be controlled by using various types of optics. It is suitable for all climates. It can be used for very targeted areas by using optics or lenses. This is a technology that is fast developing and a technology of the future. But in the current scenario, it is not finding much use as the intensities are low, the cost factor is high. It is still not viable to use this in many systems. The cost is still not viable to use this. But over the years, I think so. Like it happened with the LEDs, the cost will come down, and you can have properly tuned products to give a specific wavelength of the UV. Now, measuring equipment for ultraviolet luminous, like your normal luminous, where you provide IES files and lumen data output. Similarly, in ultraviolet luminous, if similar data for its the UV radiation distribution is available to designers, then it will become much easy to design spaces and accommodate the UV luminous in a space. So it is recommended that manufacturers start giving out this type of data, and this is a spectrogoniometer that is being used for such an application, also for finding out the distribution of UV radiation. For the lumen output, you can use an integrating sphere. For example, sorry, not lumen output, it's the radioactive, the radiation, the UV radiation output. Sorry on that, it is not lumen output, it's the UV radiation. The effect of UVC on human beings. One is it affects your eye. Normally, it affects the cornea of the eye, which causes reddening and reddening of the eye. It is very painful Normally, the cornea effect gets rectified in a day or two, but the phobic effect is there for nearly a week, and it is nearly quite painful for a week or so. Then the next one you have the erythema or redding of the skin, where you have skin burns and skin irritation. Even this normally recovers in a week's time as such when the dead skills are the upper layer of the dead skills is replaced by the human body. There are a lot of studies that have shown that UVB, because of its high penetrative, because of the wave having the medium wave having high penetration levels as compared to UVC, is more dangerous for photocarcinogenic effects, which causes the skin cancer. Most of the hazards that occur in UV installations is either due because of the access to the radiation and the duration of the exposure time. For example, in air handling units, if an unqualified or untrained person tries to access this when the lamps are on, he can get exposed to the UV radiation. Similarly, if you have not installed properly luminaires for GUV applications, then they may either give direct output affecting people or reflected UV rays again affecting the people working around in the area. Access and maintenance SOPs for induct systems and upper air systems should be put in place when you are installing such systems. These are some effects of UV on materials. For example, there is a very bad effect on paints, which degrades them very fast or ages this paint very fast. Then you have the yellowing of plastics, where the plastics start turning yellow fast or age fast. When these plastics are exposed to continuous UV radiation, then the upper layers of the plastic start becoming brittle and start giving off in powder form. You can normally find this when you have some plastic lying in the sun for very long. In such cases, the upper layers, the first of plastic is completely faded if it is colored, or if it is white, it has turned yellow. And the upper layer starts, hold it in your hands, you have some powdery things falling off it. UVC also causes damage to plants. So when you're doing UVC in rooms, care should be taken that plants are not there in the rooms or it can destroy these plants. Person handling UVC should have proper personal protective equipment. One is UV protective eyewear. Of course, use a product which is compliant with the standards. You have face shields. You have gloves. It is recommended to use nitrile gloves. PPE coats made of tightly woven heavy fabrics or heavy cloth. As such, special care should be taken to cover up your neck and exposed areas of the face. And you should always wear shoes when doing this, or your feet may get affected, or the upper part of the foot may get affected, which can get exposed to the UV radiation if you are operating it. These are some of the standards for photobiological safety of luminaires, and The IC 62471 or the BIS 62471, which are more similar. You have to put the luminaires in the proper sector, the proper classification of the hazard level. You also have the ISNA RP27. Now, recently there was a statement from CIE showing the maximum exposure limit of humans in particular wavelengths, which showed in this table here. For example, for 270 nanometers, it is around 30 joules per meter square. Question notes. Nowadays, your markets are being flooded with such type of equipment as shown in these pictures. Now, many of these equipments do not have any proper labeling. They do not have any warning or danger markings. These are openly sold directly to uneducated consumers. There are no testing or certification marks on these products. So, this is going to cause heavy damage to people using this. For example, there are many vans, handle vans that have popped up in the market. But what is the effectiveness of these vans? And there is no such data available because the UV dosage to inactivate surfaces by these vans is very difficult. Or it may when you use these products, it may give a false impression that area has been disinfected, where actually the disinfection is not proper or not fully disinfected, or the level of disinfection is not there as required. I think so the government should put in some kind of regulation on import of such materials which is flooding our markets. If you open your emails, I think so each one of you must have seen with the flood of such products coming from our neighboring countries, or many Asian manufacturers. These are some statements issued by some world bodies. One is the CI. There was a long statement issued by the CI stating their position on the use of UV disinfection, and this is the summary of that statement. Similarly, a statement was issued by the Illumination Engineers Society. This statement was issued after a lot of consultation with the US CDC, the FDA, and the Department of Defense. The CDC also has given out guidelines on the use of UVG. So, coming to the conclusion, uh, technically UVC is a very good tool to use for disinfection or deactivation of viruses. You should take great care that the equipments are handled properly and do not cause a high risk to the users or people surrounding the users. Organizations like the ISLE, BIS, ELCOMA, and such should issue suitable caution notes to investigate further through Ministry of Health or our research organizations before a flood of equipment coming in from outside floods our markets and causes damage to the people. There should be strict standards and approval norms set before they are imported or manufactured or assembled in the country. I conclude the session here and open the floor for question and answers. I once again thank the members of the ISLE and all of you who have attended and taken off your time to attend this webinar. I also like to thank all those who have been part of organizing this webinar and giving me a chance to present this. Such events will be continued further by ISLE again. Once again, thank you and stay safe. Goodbye.